rational function. Okay, first before you sketch the graph of the rational function, first here you find the horizontal asymptotes of the rational function. Okay, first you find the horizontal asymptote of the rational function using the limits at infinity. Yeah, so limit as x here approaches positive infinity of fx, and here equals to the L. L here represent the constant, any value, negative or the positive value. Yeah. And second, you find the limits at infinity, limit as x here approaches negative infinity of fx, and here equals to the L. Yeah. So first step here, you find the horizontal asymptote of the rational function. Okay, and second, find the vertical asymptote of the function. Okay, step 2, you find the vertical asymptote of the rational function using the infinite limit. So limit as x here approaches a from the right of the function. So this one from the right of the fx, and here equals to the positive infinity or equals to the negative infinity. Yeah. And second here, from the left of the rational function, x here approaches a from the left, yeah, of fx, and here equals to the positive or the negative infinity. Okay, so here method using the infinite limits. Yeah, and step 3. Okay, step 3, you find the stationary point of the function. So you let the first derivative here equal to 0, yeah, to find the relative maximum or the relative minimum point. And using the first derivative test, you draw the table of the first derivative, the value of x, the sign of the first derivative, and then a shape of tangent, and determines the relative extremum point, maximum or the minimum point, or using the second derivative to find the relative maximum or the relative minimum point. Yeah. Step C, find the stationary point, and step 4, you find the intercept of the rational function. Okay, so we find the intercept of the rational function, x-intercept of the function here. When y here equal to 0, so you find the value of x, and then the y-intercept of the function, you let the x here equal to 0, and find the value of y here. And behavior of the function when x here approaches positive or the negative infinity, and last here you find the domain and the range of the rational function. Yeah. Okay, question 14. Sketch the graph of the rational function. Question B, y here equals to the x over x squared plus 1. Question A, your exercise. Okay, step 1, you'll find the vertical asymptote of the rational function. So the rational function y here equals to the x over x squared plus 1. And you let the denominator here equal to the 0, yeah? You let the denominator here equal to 0 and find the value of x, okay? So the value of x here equal to the third negative, okay? So no real solution for the denominator, and the conclusion you here, vertical asymptote of the rational function does not exist, yeah? Okay, step 2. Okay, step 2, you find the horizontal asymptote of the function. First here, limit as x approaches positive infinity of x over x squared plus 1. And here you find the highest degree of the denominator. Yeah, the highest power of the denominator here equals to the x squared. Yeah. And numerator divided by the highest degree of denominator, x divided by x squared, and denominator here x squared plus 1 divided by x squared, yeah? And here first x over x squared, and here denominator x squared over x squared. This one equals to 1, yeah? And here 1 over x, and denominator here 1 plus 1 over x squared, yeah? And you substitute infinity into the function. So first value of numerator here equal to 0, and here 1 plus 0, and answer here 0 over 1 equal to the 0, yeah? Okay, and second, limit as x here approaches negative infinity. This one, you check the highest degree of the denominator. Here equals to the x squared, yeah? Okay, numerator divided by x squared, and denominator here x squared plus 1 divided by x squared, okay? This one answer you equals to 1, and you substitute infinity into the function, 1 over infinity, and here 1 plus 1 over infinity square, yeah? And here 0 over 1 plus 0, and answer you here answer you here equal to the 0, yeah? So y equal to 0 is a horizontal asymptote of the rational function. Okay, step 3, you find the stationary point of the function x over x squared plus 1. So you find the first derivative dy over dx here using the quotient rules. So you find the value of u and you find the value of v here. So x squared plus 1, and you differentiate the value of x minus x and differentiate x squared plus 1, and denominator here x squared plus 1 and power of 2. Yeah, and the first derivative, you check answer, equals to the negative x squared plus 1 over x squared plus 1 power of 2, and you find the stationary point of the rational function. Okay, so the stationary point of the rational function here exists when the first derivative equal to the 0. Yeah, so you let the first derivative here equal to the 0. Negative x squared plus 1 over x squared plus 1 and equal to the 0. Okay, and here denominator you cross multiply times 0, and here negative x squared plus 1 and equal to 0, and factorize the quadratic function. First factor here 1 minus x times 1 plus x and equal to 0, and you find the value of x. X here equals to the plus minus 1. Yeah. Okay, and find the coordinates of the stationary point. First value of x here equals to the positive 1, and you substitute into the rational function. X over x squared plus 1, and value of y here equals to the 1 over 2, and the first point 1 over 2. Yeah, and second point negative 1, and you substitute into the function, and value of y here equals to the negative 1 over 2, and second point negative 1, negative 1 over 2. Yeah, and you find the relative extremum point using the first derivative test to determine the relative maximum or the relative minimum point. Yeah. Okay, so you all draw the table of first derivative. First here, you check the value of x. You put the value of x, and second row, the first sign of the first derivative, dy over dx, and last here you put the shape of tangent. Yeah, and determines the shape of tangent, and conclusion you here relative maximum or the relative minimum point. Okay, so first value of x here equals to the 1. Okay, so first value of x here equals to 1, and you substitute into the function. Okay, and find the sign of the first derivative, and here from the left here, the nearest value x here equal to the 0. Yeah, and you substitute into the first derivative and sign here positive, and the shape of tangent increase. And then at the center here, x equals to 1, substitute into the first derivative, value here equal to 0, and here you put the horizontal line, and then from the rest of the function, the nearest value equals to, and the sign here equals to the negative, and the shape of tangent here decrease, and conclusion you here, 1 over 2 is the relative maximum point. Okay, second value x here equals to the negative 1. From the left here, the nearest value between negative infinity and negative 1, the nearest value is negative 2. And from the right of the rational function, value of x here equal to the 0. Yeah, you substitute into the first derivative. From the left here, sign negative. At the center here equal to 0. So from the left, shape of tangent here decrease. And here horizontal line, and then here after 0 here graph shape of tangent here increase. Yeah, and conclusion negative 1 over 2 is relative minimum point. Okay, and step 4, you find the intercepts of the rational function. Okay, first here you find the x-intercept of the rational function. You let y here equal to 0, and you find the value of x. 0 here equals to the x over x squared plus 1. And here you cross multiply, and the value of x here equal to the 0. Okay, so x-intercept of the function at the origin. And second, you find the y-intercept of the function, x here equal to 0, and you find the value of y. So you substitute 0 here into the rational function. 0 over 0 plus 1, and value of y here equal to the 0. Okay, and y-intercept of the function here at the origin, x equal to 0, and y here equal to the 0. Okay, step 5, you sketch the graph of the rational function. Okay, so first you plot the point, the relative minimum point here at the negative 1, negative 1 over 2. And you plot the relative maximum point at the 1 over 2. And the vertical asymptote of the function here undefined. And the horizontal asymptote of the function y here equal to the 0. Yeah, so this one the horizontal asymptote. And you draw the graph of the rational function. From the left here, start from the negative infinity. Okay, and start from the negative infinity, and graph here negative 1, negative 1 over 2, and here you put the intercept at the center, at the origin, at the 0, 0. So you plot the intercept of the function here at the origin, and relative maximum point 1, 1 over 2, and graph here to positive infinity. Yeah. Okay, step 6 and step 7, you find the domain and the range of the function. Okay, domain of the rational function here, all the real numbers, negative to the positive infinity. Domain of the rational function is all the real numbers except the vertical asymptote. Yeah. Okay, and range of the function, the lowest value of y here equals to the negative 1 over 2. You check the value of y. So this one, the lowest value, negative 1 over 2. And the highest value of y here, the maximum y here equals to the 1 over 2. So range of the function, bottom ups, start at the negative 1 over 2, include negative 1 over 2 to the positive 1 over 2. So the range of the function here using the closed interval. Yeah. Domain of the function from the left to the right of the function, and the range of the function here bottom ups. Yeah. Okay, so last you check the behavior of the function. Okay, so you check the behavior of the function when as x here approaches positive infinity. So x here approaches the positive infinity. Start at the x equal to the 0. Maybe start from here, x equal to 0, x equals to 10, x equals to the 100, 100,000 to the positive infinity. And the value of y here equal to 0 at the positive infinity. Okay. Okay, as x here approaches positive infinity and y here approaches 0 at the positive infinity, and you check the graph here. If the graph here above the horizontal asymptote, you check here above the horizontal, and here you put the positive sign. Yeah. So here y here approaches 0, and here you put the positive sign. Okay. And second, when x here decrease to the negative infinity. Okay, so decrease to the negative infinity, start at the origin, start at the 0 here, -1, -10, -100, -100,000, yeah? And here, y here approaches 0 at the negative infinity. And you check the graph here. So your graph here below the horizontal asymptote. Okay, so here you put the negative sign. Yeah. Okay, so below the horizontal asymptote, so here you put the negative sign. Yeah. Okay, and graph here, you labels the function. Okay, so you label the function fx here equals to the x over x squared plus 1. So the graph here, you labels the relative maximum, 1 over 2. So here you label the relative minimum point, -1, -1 over 2, intercept of the function, and then graph here fx equals to the x over x squared plus 1. Okay, settle. Okay, rational function step by step. First here, you find step 1, you find the vertical asymptote of the rational function, and method using the infinite limit. Using the infinite limit, so you find when x approaches a from the left of the function equals to the positive or negative infinity, and second, x approaches a from the right of the function and determines the sign of the infinite limit. Okay, step 1. Step 2, using the limits at infinity, you find the horizontal asymptote of the function as x here approaches positive or the negative infinity of the fx. And step 3, find the stationary point of the rational function you let the first derivative equal to 0 and find the coordinate of the stationary point. And using the first derivative test or using the second derivative test determines the relative extremum point, the relative minimum, or the relative maximum point. Okay. Step 4, find the intercept of the function, y-intercepts and x-intercept of the function. Okay, and step 5, sketch the graph of the rational function. You plot the maximum minimum point and plot the intercept of the function, and you sketch the graph of the rational function. Okay, and step 6 here, find the domain and find the range of the function, and last you find the behavior of the rational function. Okay, dan class step 3, first derivative test or the second derivative test. Antara dua ini saya galakkan you all pakai first derivative test. Okay, lagi mudah dan lagi cepat. And quadratic function, cubic function and quadratic function, kalau you all nak cepat, better pakai second derivative test. Okay, tapi di sini you all boleh pilih sama ada first derivative or the second derivative test.